Hi everyone, welcome to another ALEKS tutorial video. We're going to be looking at more trends now. This is periodic trends in ionizability. Weird word. Alright, so in this problem we have two sets of ionizations that are shown in the tables, and we want to choose one, the number 1, next to the ionization that would require the least energy, and then followed by the next least energy for 2, and so on. So, little review. We covered ionization energy in one of the previous videos. Ionization energy is the minimum amount of energy required to take an electron from an atom. So, just like atomic size that we covered in the last video, there is a periodic table trend. So, going up the periodic table and to the right, we have a increase in ionization energy. So, we're given these elements, and we want to know which ones have we want to order them from least ionization energy to most, I believe. Yeah, least to most. And just to cover the concepts a little bit, when you have something like helium, you've got 2 electrons that are surrounding the nucleus, and these electrons are very close to the nucleus. So the force between the positively charged nucleus and the 2 electrons surrounding the nucleus is going to be extremely strong compared to something like francium. So it's no coincidence, therefore, that the increase in ionization energy is directly related to atomic size. As in the last video, we discussed how the same trend corresponds with a decrease, this decreasing atomic size. So as your atomic size gets smaller, the electrons are closer to the nucleus, and therefore experience a greater force pulling them inward. And so it makes sense that ionization energy, which is the amount of energy required to remove an electron, is greater than the amount of energy required to remove an electron from something like francium, which will have an electron all the way over here. And so it'll experience a lot less of a force, a lot less of an attractive force. And so the ionization energy is a lot lower. for something with a big atomic size. So with that being said, for this first table, we'll deal with the first table. We've got this Bi element, which is bismuth, and that is right here. We have Br, which is bromine, and that's right here. And then we have Ra, which is radium, and that is here. So we want to start with a 1 next to the ionization that requires the least energy. So that's going to be radium. Radium is also going to have a very large atomic size. It's one of the largest atoms on the periodic table. And so it is going to have a low ionization energy. Oops, that's not radium. This is radium. Let me do this in another color. That's not a good color. Oh my goodness. How about orange? There we go. Radium. So this is number 1. And then following our trend, we get to bismuth. That's going to be the next lowest or the next highest ionization energy. And then bromine is the farthest up and to the right. And so that's going to have the highest ionization energy. That's going to be the most difficult to remove an electron from. And let's switch to purple and do the next table. So this is not titanium. That's an L, not an I. And that is going to be thallium. This would erase. All right, thallium. That's the first one. And then we have S, which is going to be sulfur. That's over here. And Se, which is selenium, and is right under sulfur. So as we can see, the lowest ionization energy is going to be thallium. So start with a 1. Next up, selenium. Selenium gets the 2, and then 3, the highest ionization energy, goes to sulfur, and that's a 3. Pretty simple, and that's it for this video. Thanks for watching.